Okay? Anybody know how to define a polygon? What's a polygon?
Is it like equal sides?
Equal sides.
I don't know. I always forget what it's called.
It's closed. Okay? Alright. Alright, so I'm hearing a couple of different things. So for example, okay, I heard it's closed. Is that a polygon?
No.
Why not?
Has to be straight. All straight.
Has to be straight. Okay. Alright. So let's get rid of that one. Alright. You did say it had to be closed, yes? Alright. I don't know why it's not giving me. Alright. So can I have a polygon that looks like this? Is that a polygon?
No.
No? Because it's not closed, right? Okay. So what if I had this situation? That's closed.
No.
Is that a polygon?
No.
Why not?
Lines can't intersect.
The lines can't intersect? Okay. Let's try
So
this.
basically you can't see.
That's why there's a 1, 2, 3, 4. Okay? Can I have this situation?
No.
No.
Line's not straight.
Okay. So if we were to come up with some, concepts on polygon, so based on what we've said, what would be a couple of rules or concepts that we need to know?
Don't they have to have like 90-degree angles?
Do they have to, did we talk about 90-degree angles in any of the examples that we just went through? No. Okay. So what was one of the things that you said can't happen or could happen? Yeah.
No, just
All right. So sides cannot intersect. Okay. So what that means is you can't have a shape like the hourglass figure. Okay. All right. What else did you say? What was another stipulation? Say it, Mary. Has to be closed. Okay. So it has to be like this versus, something like this. All right. So make sure you understand what it means versus closed. All right. What else did we say? Why did we throw out the circle?
Has to have straight lines.
All right. So sides are straight lines. Okay. So no curves, basically. All right. Anything else? All right, so then the last thing is just make sure that you understand in terms of a polygon. I don't know in English classes and stuff, you guys talk about prefixes and suffixes. What's poly mean?
Many.
Many. Okay, so basically a polygon is simply a many-sided figure. All right, and to define many, can I have a two-sided figure? Can I have a three-sided figure? What's that three-sided figure called? All right, so just understand polygon is a general term. Triangle is a more specific term, okay? Like you are all sophomores, but more specifically, you have a name like Javier and Gabby and things like that. So, we can, you have different names, okay? All right, so vertex. A couple of things just to understand here. Vertex in terms of a polygon is basically your corners. Okay, if you need to write that down, it's just the corners of the figure. They're called vertices. Okay, and then we get into this concept of convex versus concave. Does anybody know the difference between the two? Convex versus concave. Charlie? Cave goes in. All right, so what that means is if I had the following figure, okay, this is concave. All right, see how he said it kind of goes in, it sinks in on itself. All right, true definition, okay, if we were to go like book to book, if you were to connect any two vertices, like this vertex and this vertex, if I connect them with a string, if that string is outside of the blue figure, like it is in this picture, that makes it concave. So if you can ever connect two vertices and that line is outside of the figure, that makes it concave. Okay? Whereas if I were to do something like a pentagon, like this, can I do what I did with the red line on the concave? Is it possible to connect two vertices and have that red line be outside of the figure? No. Okay? Every single time I connect one vertex to another, vertex to another, vertex to another, vertex to another, so on and so forth, notice all the red lines are inside. Okay? What are those inside lines called? Begins with a D.
Diameter.
Not diameter. But it is a DIA. DIAG. It's a diagonal, okay? All right? So a diagonal, okay? Not a diameter, all right? So make sure you understand, what a polygon is, all the different pieces. So things that you're going to have to be able to do is look at a polygon and say yay, nay, and then classify it, okay, using other words that we're eventually going to come up with, okay? All right, like, well, the equilateral, equiangular, so on and so forth. All right, so example number 1. Is it a polygon, and if it is, concave or convex? So, A,
Concave.
is it a polygon? It's not even a polygon. Okay, why not? Because of the intersecting that line that's on the inside. All right, so B, is it a polygon? Concave or convex? So it's convex. Okay, C, concave, convex, or not even a polygon? Not even a polygon because of the curved side. D, concave, convex, or not a polygon? I heard convex and then I heard concave. Convex? All right, so I'm going to test, okay, using what I talked about with the lines. I am going to draw a line from one vertex to another. Is that line outside of the figure?
Yes.
All right, so what does that mean? Concave. Notice that this line and this line, these kind of like caved in on the figure, all right? So it is concave. All right? All right, down here, okay, just be familiar, okay, with terminology. My expectation is if I give you a 7-sided figure, you would be able to use the word heptagon, okay, all right? All right, octagon. If you're in driver's ed, you see them all the time with the stop signs, okay? The n-gon concept is if I give you a 15-sided figure, you can now just say, since it's after 12, you can just say 15-gon. So that's what n-gon means. So if we have a 18-sided figure, you could just say 18-gon, okay? Questions there? All right, page 2. Okay, so what I did there was I underlined the decagon. Notice decagon is again do, short for dose. What's dose? 2. So what's 2 plus 10? 12. Okay, so how would you say 1? All right, so I think you said undagon or something, but it should be un decagon. Okay, so like dos, okay, uno, so 1 plus 10, so un decagon. All right, so we're to page 2. Okay, this is where we're going to continue with the classifying. Equilateral, equiangular, regular. Okay, so based upon your concepts of words, equilateral. What's equilateral?
Equals the sides equals?
a triangle with all sides equal. Now, we are talking about polygons, not just triangles.
All sides are equal.
All sides are equal. Does it have to be a triangle?
No.
All right, so essentially it is a polygon with all sides equal. Okay, now she talked about, an equilateral triangle, but it could be a square,
Study hall teacher wants a pass for her to go to lit lab and needs.
triangular. All right, so a polygon with all angles equal. Okay? And FYI, in the future, we're going to say congruent instead of equal. Regular. What do you think regular means? Any guesses? What do you want to say? Just a normal polygon with no equal sides, no equal angles? Okay, that's a good guess because the other ones are equal, so regular is probably not equal. Anybody else? Ooh, ding, 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 ding. Okay, winner, winner, chicken dinner. All right, so regular means, okay, all sides and angles are equal or slash congruent, since we're eventually going to get to that. Okay? Yes? Yeah. All right, so big thing that I do want you to understand, okay? And you know what, actually, we'll come back to it after C. We'll do A, B, C, and then we'll come back to it and see if you guys can come up with the idea. All right, so A, you have to decide, equilateral, equiangular, or regular. If it's regular, always say regular. If it's one or the other, then just, use the appropriate one. So, A,
Regular.
regular. Notice tick, tick, tick for all the sides. All the angles are the same. So this one is regular. Okay? B. So remember that in order to determine whether or not all the sides are the same, they all have to have the same tick marks. The angles all have to have the same tick marks. So what's B?
Equilateral.
I heard equilateral.
Nothing?
Nothing? Nothing? What about regular? Can it be regular and not equilateral or equiangular? No. Okay, so this is nothing. Okay? Nada.
That wasn't even one of the options.
I know, but you got to think. Okay? All right? C. I heard regular. Anybody else? Andrew, regular? Anybody else? You're shaking your head. What are you thinking? What? Nothing else? So like it's not equilateral, equiangular, or regular? It's regular? All right. FYI on this one. Okay, so this is a point that I was going to make earlier, but now I wanted you to discover it. And I am going to say that it is equilateral and not regular because it's not equiangular. Think. Jesus, you said, oh. Explain. What? No. I think you got it. You sure? I thought I saw the light bulb go on. Because it looked like you were going to draw something. Okay? So if I take a look at this picture, what can you tell me about this angle? No, that's inside the figure. So the question is it 90 degrees? Is that blue angle 90 degrees? No. Okay? But this angle is 90 degrees. So in order for it to be equiangular, all the angles have to be the same. Okay? And these, in this case, they are not. Okay? So, understand this is not equilateral. So the point I was going to get to earlier, okay, is that for regular, it will never, sorry, I should back up here. A concave polygon can never be regular. Okay? A concave polygon can never be regular. Okay? So, at some point we're going to have those always, sometimes, never type questions. Well, here's a never for you. And the reason is because when it caves in, it changes the inside angle. So this inside angle will never match one of these. Like this will either be right or acute, and this will always be like obtuse. Okay? So it can never be regular. All right? All right, from the rest, all it comes down to now is making sure you understand this idea of equilateral, equiangular, and regular so that we can apply it to our algebra skills. Okay? So the expressions represent the measure of two angles of a regular nonagon. What's nonagon?
9.
Very good. Find the measure of an angle of a nonagon.
Oh, sorry.
An angle means one angle. So if it tells us that 9x plus 5 is one angle and 11x minus 25 is another angle, and it's regular, what do we know about the two angles?
They should equal each other.
They should equal each other. She's on it today. I like it. 9x plus 5 equals 11x minus 25. Okay? All right, so to kind of show it in terms of a picture, if you look down here at this triangle example, see how it says that it's regular? Well, this angle and this angle are going to equal each other because they're the same measure. Now, I didn't draw out the nonagon, okay, but that's the idea that I want you to understand. All right, go. Solve for x. All right, anybody solve this one? Grace, did you get an answer? Okay. X equals 15. Everybody good with that? Are we done? No? Maddie, what do we got to do?
Plug in the x.
All right, we got to plug the value in because it says find the measure of an angle of the nonagon. 15 is not the angle measure. The angle measure is 9 times 15 plus 5. So what's 9 plus 15 times 15 plus 5?
42.
How about 9 times 15 is 9 times 10 plus 9 times 5. 135
135.
plus 5.
140.
140.
I was close. I missed the one.
Just
and
use the
minus
distributive
15.
property in your head. Okay? Example 4. The expressions represent sides of a regular quadrilateral. Now, quadrilateral is probably easier to draw, so tick, 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 tick. It's basically saying that if this side is x squared plus x, and this side is x squared plus 4, what's true about them? They're equal, so there's your equation. Okay? Now, you got a couple x squareds in there. Don't let them scare you away, because what happens when you take 1x squared from one side and put it on the other side?
There's no square.
There's-
no x.
They cancel out. So what's our final answer?
4x.
X equals 4.
That's what I.
Okay? And this one said just find the value of x. Okay? All right? All right, so big ideas for today. Do you understand whether or not something is a polygon? So, things. Can it have curved sides?
No.
Can it be an open figure? Okay? Can it sides cross itself?
No.
All right. Do you understand the difference between concave and convex? Okay? And then do you understand equilateral, equiangular, regular? All right.